everybody. I hope you had a ton of fun playing games. Math is the best. I know you all know that. So I hope you had so much fun. I want to introduce Alison Fox Mazzola. She is our math consultant. She works at schools all over the Bay Area, up and down the peninsula, being a math consultant and coach. And she has particular expertise with parent education and working with parents. So thank you. She's also been here for the last 10 years since we adopted Bridges. So she's been helping us with that transition from the very beginning. So thank you, Allison. Welcome.
You. Thank you. Good morning, everyone.
Sorry, and there's still 4 VIP seats.
I'm so glad to see you this morning. We did this event here about 6 years ago or something, and it was a really fun morning. So it's really great to have you all here for another reprise of this math morning with kids. So I hope you really had some fun with your child this morning. I heard the energy was incredible. Cecilia's already shown me some pictures. So I wanted to just start by giving you a couple minutes to chat. So I have some questions for you. So a question that you might discuss with your neighbor in just a moment is, how did your child use manipulatives to solve problems? You might also describe a conversation you and your child had as you worked, and how did this conversation play a role in building understanding either for your child or for yourself or both? Were you and your child able to share different ways of solving problems? Most of us learn math very differently from how the kids are learning it. So I hope perhaps some people had a fun conversation around that. And finally, in which ways did your child display perseverance? So I invite you to chat with someone who was not playing the game with you. Like if you are here with someone that already played the games with you, choose someone else to talk to. And I'll just give you 5 minutes or so to chat with a neighbor. So go ahead. 3, 2, 1. Woo, there's some good energy in the room. So exciting. I'm wondering if a couple people would be willing to share something you noticed in your child's classroom or something that came up in your conversation with your neighbor. We had a lot of things to talk about. I'm sure a couple people want to share. I know, grown-ups don't like to raise their hand. It's okay. Please go ahead.
So we talked about like the kids were using like visuals for rounding, using a number line with the benchmark numbers.
Yeah.
And that helped with some of the students that still needed that visual versus some who quite could understand like the other type rules, like the old school rules.
Yeah.
So there were some kids who still needed visuals and some kids who could mentally do it in their head now.
Great example. Thanks for sharing. I also like how you pointed out the differentiation. Like some kids were here and some kids were here and everyone was included. Yeah, cool. Another idea that came out of your talk. Some other manipulatives that you noticed or visual models that you were using in your game? Go ahead.
We played a fraction game with pattern blocks, and my daughter is like very competitive, and she was really into like trading them in for like the ones that she thought were the most like the best use of the space. But then we ran out of the bigger blocks towards the end, so she needed to really like think through different strategies. But, it didn't really slow her down.
Yeah. So what I'm hearing you talk about is that flexibility and having a lot of different strategies to be able to solve a problem. Cool, thank you. Did anyone have a different way to solve something than your kid?
Yeah, it's similar. So we were doing a math bingo game with multiplication. One of the hardest ones to memorize are by the nines, right?
Yes.
So she was teaching me a trick.
Yes.
I remember how to do the math, do the nines
Yes.
that she learned in school, and I taught her a trick that I learned 4 years ago.
Yeah.
To figure out which one works better. Right?
Yeah. Oh, I love that. Wonderful. If we have time at the end, we want to hear your strategies. Did anyone see their kid displaying a bunch of perseverance? Really sticking with something that was tricky? Even your explanation of the pattern blocks, you ran out. Well, instead of saying, we're done, just continuing to try things to move forward. Yeah. Other examples of perseverance? Go for it.
We had kids playing they had the number board and they had markers that they had to move heads and tails up and down.
Yeah.
And there was a point where they couldn't move down, and so it was like, they kept playing and then somebody in the team comes up, well, do your heads and tails, we could figure out if you go up. And it was nice, right? I mean, it was kind of trying to figure out of the box to how to make or solve that problem that they were stuck there.
Yeah, I love it. So they had a problem, and then they were brainstorming some ways that they could work through it. Terrific, thank you. All right, so I wanted to put a little frame around what you saw this morning. These are all the pieces of bridges. So this morning you played the workplace games, which is this piece, but there are 3 other pieces to the program. The first piece is the problems and investigations, which is a time when the teacher introduces some exploration to the class and they engage together in discussion about something that they're working on at that moment. And that is roughly 40 minutes, really depends on the grade. The 5-year-olds cannot sit still for 40 minutes, but it's roughly about 40 minutes for the bigger kids. And then that's balanced out with the workplaces time. So the workplaces time, which you saw today, is similar to what a lot of us did in school, which was worksheets. But you can see it was way more fun. And you got to work with a partner, and the kids will play the games over and over and over because they're having so much fun with it. So unlike a worksheet where you and I might have gotten to the bottom and said, here you go, I'm done, I'm out, is it recess yet? The kids love playing the games, and they will continue to play. They're also building some social skills of playing that game with a partner, and what do you do if you disagree about what should happen? And do you lose a turn if you can't go, or should you just spin again? There's some negotiation going in there. But it's really that practice time. It's also the built-in differentiation time in the program. And you mentioned the differentiation a little bit. And it's a time where kids can play the games at different levels, but also the teacher, because everyone's playing games, the teacher is able to like nestle in with a small group of kids and work with them on something that they particularly need. That's all balanced out by Number Corner, which some people like to call it's calendar on steroids, because there's so much more to it than just calendar. We're not just doing the date and the weather and things like that. We're doing measurement. We're figuring out different ways to express data. There's a great one in 5th grade. This one's actually for October, where they're doing a lot of measurement and data collection and graphing things. So in October in 5th grade, they dehydrate carrots. So you just leave the carrots on the counter. They don't mold. I haven't seen one mold yet, though I thought they would. But the kids have to at first figure out how many grams a carrot is. And you ask the kids, and I get predictions from 5 grams to 5,000 grams. But then we actually weigh them. We get 2 carrots, and we find out how many grams they are. And then over the course of the month, they lose weight. Unlike most other things where we're always gaining, even kids are gaining weight, right? Because they're getting bigger. But these carrots are losing weight, and so they have to measure them every day, and they graph it. And so that's part of Number Corner. A lot of the fact fluency work is part of Number Corner. So there's just fun things happening every day in Number Corner. And then that's balanced out with some home connections and student books. The student books are like practice pages that the kids are using in class after a discussion, and they're working through something more independently. So they have a chance after all the group work to just do some independent work, think about something, there's some challenges in there and so forth. All right, so overarching all this work that we're doing in math are something called the math practices. So you know the skills that your child is working on. You played today a game about fractions or multiplication or rounding or whatever, but there's an overarching set of habits of mind that are called the math practices. These math practices are the same from kindergarten to 12th grade. But of course, what a 5-year-old can do looks very different from what a 15-year-old can do. But I like that they're the same because we can keep coming back to them over and over and over again. So the math practices, there's 8 of them. And they're usually presented in a list, but I don't like them in the list because it feels like you have to go from one level to the next level to the next level. So I re-represented them in a circle because I feel like these are all part of building a strong mathematician. So I wanted to just walk through them with you so that you have an idea of what they are, and we heard a couple of them this morning. So the first one is make sense of problems and persevere in solving them. So I've had students, I've given a challenge problem and they've crumpled it up and thrown it back at me and said, this is impossible. Why would you give me something impossible to do? So can a child stick with something for a while, and if they get frustrated, come back to it tomorrow and work on it later? You know, it's very rare in the world of mathematicians, grown-up mathematicians, that you look at a problem and solve it right there and then, right? We have to stick with things for a long time, which is, by the way, a fabulous life skill. that we all need for so many things that we're doing. Anybody still working on their New Year's resolutions, or have you dropped those? The next one is reason abstractly and quantitatively. So that's, can you take some numerical representation of something that's happening and figure out how to like make an equation with it. Here's a great example. I was working with, they were actually 7th graders, but I know we're not having middle school parents in here, but the story was we brought 3 cookies to share with the class. Every person was going to get a quarter of a cookie. These must have been really large cookies. But the kids had to decide, would we then do 3 divided by 1/4, 3 times 1/4, 3 plus 1/4, or 3 minus 1/4? And the kids had absolutely no idea in this particular class. And I said, would someone like to at least speak for one of these equations and so we could rule it out? And they just really had no idea what it would be if you had 3 cookies and you divided them into 4ths and then shared them with the class. So how do we quantitatively express what we're trying to talk about? I won't tell you the rest of this story, but it was a hard day. Okay. So the next one is actually my most favorite math practice. I love this one. Construct viable arguments and critique the reasoning of others. So can you explain your thinking to someone else? Can they listen carefully and respond back? The words are critique the reasoning of others, but I actually don't like that word critique because we're not necessarily saying it's a bad idea, I don't like it. But we have to take your idea, put it into the brain, and then decide, oh yeah, my idea was really similar, or I did it very similar, but this part is different, or wow, I came up with something completely different. And I love this math practice because I think it also is so much a life practice. I mean, so much of our day is spent considering other people's perspectives and points of view, and then deciding how we're gonna respond to those. So I think it's math, it sure is, but it's life too. All right, the next one is motto with mathematics. So this one is about having context and then making it mathematical. So I know 3rd grade is going on a field trip today. So if they're going on a field trip, and there's so many kids, and I don't actually even know where they're going, but let's say they're going to a museum, and it costs this much per kid to go to the museum. How much money do we need to spend to take all the kids on the field trip? And also, how many cars do we need? So you're taking a life situation, and you're putting the math behind it to model what's going on. Math practice 5 is use appropriate tools strategically. So a lot of those manipulatives you saw are tools, but also thinking strategies like the rounding on the number line and deciding what to do with that. Or there's like 4 different ways we could do subtraction. Which way do I want to use for this particular problem? But the key word here is strategically. And when I was in school, standard algorithm, all day, every day, for every operation, that was all we ever used. There's no strategy involved if you're using the same strategy all the time. So the idea here is that kids have a toolbox, a virtual toolbox of different strategies that they can choose from to match the particular problem. I'll share a quick example. Those of you who have heard me speak before know this story, but it's just so classic. So I was playing a Bridges game with a little boy named Austin. This school had not yet adopted Bridges, so Bridges was very new to them, and they were practicing standard algorithm every single morning, before, like right when they came into class. So Austin and I were playing this Bridges game, and we turned over a card, and the card had coins on it. And the little story was that we were going to the movies, and we were at the snack bar, and we had $5 to spend. So we turned over the card, and it would tell us how much we were spending on our snacks. So he added up all the coins, and he said, we're going to spend $4.99. Great job, Austin. You did a great job counting up those coins. We have $5 to spend. How much change should we get? Well, he wasn't sure. They'd been practicing standard algorithm every single morning, and he didn't actually have any paper with him. So he looked at me for a couple of minutes. He said, can I go get paper? Sure, go ahead. He went and got a piece of paper, got a pencil, came back, 5, 0, 0. His pencil broke, of course, right? So then he had to go get another pencil, came back, -4, 9, 9. Now he's got to borrow all the way over from the 5. And he looked at me and he said, I figured it out, Mrs. Mazzola. We get 1 cent change. This is 5 minutes since we finished adding up the coins. I said, you are absolutely right, Austin. That's totally true. You got the right answer. was that the most efficient way you knew to solve that problem? And he looked at me and he said, that's the only way I know to solve that problem. We practice that every single morning, standard algorithm. I said, I think you know another way. You know what my brain did? My brain was counting. So I was counting 495, 496, 497, 498, 499, 500. One jump. And he said, oh, I did know that way. That was a lot faster. So just an example of how not every single strategy matches every single problem. And so we want our kids to be flexible mathematic thinkers. The next one is attend to precision. Yes, we do still want them to get the right answer. But we want them also to use appropriate math vocabulary. We want them to make careful sketches and drawings. We want them to use the numbers that are in the problem, you know, things like this. If you think about some of the math words, they're very different from the words we use in everyday life. So I was working with a kid on Zoom. I was doing some tutoring, and we were doing some measurement, and I said, okay, Aksh, how big is a yard? And he looked at me. I said, well, just like show me, like, is a yard like this big or this big? Like, what are you thinking roughly, how big is a yard? And he said, hold on, I'll be right back. But where is he going? So he got up from his chair. I couldn't see where he was going because we were on Zoom. He ran to his bedroom window, apparently, and he looked out, and he came back. He's like, my yard is really big. So that's one of those words that in math is totally different than what it means in real life, right? So being careful with the math words that you're using. The next one is look for and make use of structure. It's really about using patterns. What do I see inside this problem that will help me solve it? Here's a great one. I was working with a little girl and we solved 3 times 4. We got 12. We built it. We built an array with color tiles. And then a few minutes later, we solved 4 times 3. And she said, oh, wow, look at that. It's the same. I said, let's cut out some paper and match it up and measure it and make sure it's the same if we just turn it the other way. And then she got into math practice 8, which is look for and express regularity in repeated reasoning, because she said, if 3 times 4 gives us the same area as 4 times 3, what about 5 times 6? Let's try it. And then 6 times 5, right? What about 7 times 8 and 8 times 7? I mean, to us adults, it's like this is not even a problem. But when you're 8, this is really exciting to find out. And then she said, what if we skip? What if we do 4 times 6? And 6 times 4. We spent over an hour playing with this, but she was seeing how what she knew from one problem could be carried over to solve other problems. So these are the overarching ideas I hope you saw some of today. You were talking about your child trading in the pattern blocks, and so they were finding which tools that they wanted to use and being strategic about here are the blocks that we have available. I forget some of the other examples, but a couple of them came up in our conversation. So just think for a moment, did you see your child using any of these today? I bet you did. I bet you did. All right. So this is the other piece I really want to share with you. Jo Boaler is a professor of mathematics education at Stanford, and she studies how we learn math. And she studies the best ways for us to be teaching kids. She has done so much cool work because at Stanford they have all the fun toys. So they have the MRI machine, they can put like nodes on the brain, figure out what happens. This is stuff we didn't know 30 years ago, and we definitely didn't know 60 years ago. But she's given us teachers so much information about the best ways to approach math. But this is my favorite slide of hers. It's so awesome. Let me show it to you. So she had someone go in an MRI machine, and they were, it's an adult, and they were solving the problem 5 plus 8. So it's just a math problem. Almost all of us have memorized this as a kid in school. We all know 5 plus 8 without really any difficulty. But she found that the working memory piece of the brain lit up, true. She found the attention control lit up, we're paying attention to the problem, all right. Episodic and semantic memory systems. So all of these have to do with memory and focus, right? Not really a lot of surprise there. This is the cool part. Come over here. This part lit up. Processing quantity information in visual spatial formats. The person's just doing 5 plus 8, but they were thinking in a visual format. And then processing number information as visual symbols. Again, another visual piece lights up. So when I was in school, we just learned everything through memorization. So we were only being taught with 3/5 of the brain in mind. But a really key component of the Bridges program is using those visual models. The pattern blocks, the number lines, someone else said they were using the clock, all these color tiles to make arrays, all these visual models make sure that we're teaching kids with 5/5 of the brain. Better, right? Better. All right. So I wanted to then give you 8 easy tips for helping your child. These are all easy, I promise. So the first one is to go and read the Bridges Family Newsletter. Hopefully it's come home from with your child. There's one for every unit of Bridges. If it got lost in a backpack, left out in the rain, something, you didn't get it, I don't know, go to mathlearningcenter.org, click on Families, click on your kid's grade, and you can read the newsletter. And it comes with every unit, so you can see what's coming up next. Yes, please.
Can we get a copy of this presentation?
It's going to be on video. I'm being recorded for YouTube. You can watch the whole thing. All right, next, second easy tip. Play board games together. Such a fun, easy way to do math. I put a couple up here. Prime Climb is a real favorite for the older kids. Tiny Polka Dot for the little ones, even games like Yahtzee. First of all, you're helping your kid just develop a lot of those social skills of what happens when you lose a game, right? But also using the dice, using the visual models. The kids are taking in a lot more math than you might realize. So doing math with your child does not have to involve worksheets. It could be some fun family time of playing a game together. All right, number 3. This sounds silly, but this is actually really important. Put an analog clock in your child's bedroom. It sounds ridiculous, right? We're all using digital clocks. But let me show you what we can do with the analog clock. If we count the minutes as we go around, it's also a representation of multiplication. So if you know when the long hand is here, you're on the 4. These are groups of 5 minutes. 4 times 5 equals 20. Easy. If you know when the long hand is on the 8, 8 times 5, well, you know that's 40 minutes, equals 40. So we can use the clock for multiplication. We can also just use the clock for telling time, which is a 3rd grade standard, 2nd grade also. But look at how we can also use it for fractions. This is from 5th grade. So we have what is 2/3 minus 1/2. So I shaded in 2/3 of the clock here. And then I subtracted 1/2. So in order to do that, I used the comparison strategy, and I compared the two, and I found out that when I compared 2/3 and 1/2, there was 1/6 left. I don't even need to know common denominators to solve that. I just need to color in some clocks. Put a clock in your kids' room. So many kids don't have them anymore. All right, along the same lines, tip number 4. Give your child some coins and bills to touch, use, play with, and sort. Again, we don't use coins anymore. You probably have a bunch lying around your house that you don't want to keep in your pocket. Give them to your child so they can play with them. When my kids were super little, they would just sort them by size. First, they just sort them by color, which is pretty easy. Then they'd start sorting them by size. Then as my kids got older, they would sort them by date. Look for the date or the mint place, like some of them are made in Denver, some of them made in San Francisco, like that. But look at all the math we can also do. Decimals, yeah. I just had a kid tell me recently, she said, I really want to work on decimals. I don't know anything about decimals. I said, I bet you actually do. Can you write $1.07 just on the board? So she did. I said, look at that. $1.07, you actually put a decimal in there, it's decimals. So it's math right there. We can also use it for fractions. This is $0.25 plus $0.20 of a dollar, which is a nickel, equals 3/10 of a dollar because it's 30 cents or 3 dimes. We can use it for weight. Did anyone know that 10 pennies is about an ounce? Cool, huh? We can use it in a pan balance. You can make one on the line. We can also use it for place value using our dimes and pennies. So give your child a collection, just a little container of some coins they can play with, they can sort, they can use. If you're going on a trip, give them some money. $10, it has to be a small enough amount that they'll get a lot of change, right? So $10 and they want to buy this trinket that's $2.43, they're going to get a whole bunch of change back and they have to count and make sure that they got it right. So I've hit a lot of grade levels here that would really benefit from using coins. Give them some coins. All right, tip number 5, cook together. Double a recipe, triple a recipe. I used to do this a lot with my daughter. I would say, oh, today only the 1/4 cup is clean. We have to cook the whole recipe only using the 1/4 cup. That was when she got a little better at it, right? But you can also do water play. How many pints fit in a quart? You know, how many teaspoons fit in a tablespoon? I bet you there's a lot of people who don't know that one. So just cook together. It's fun, and you'll make dinner. So there you go. All right, tip number 6, read a math picture book. I have a ton of math picture book suggestions on my website, which is elementarymathforparents.com. These are just a couple of them that I have read recently. I've read these like in the last couple of weeks that are just really fun. You know how to read to your kid. I bet you do it a lot. It's so easy. It's so fun. Just read some books together that also have to do with math. And a research study just came out. 3 researchers studied 22 years of studies, I think, about math and picture books, and they found that it actually increases kids' skill in math, even though we're reading them books. Another interesting point, recent research has found that skill in math shows up through the end of middle school how kids are going to do even in language arts. So if you're doing better in math at 4 or 5 years old, you will do better overall, not only in math, but also in reading by 8th grade. The effects last all the way until 8th grade. So read some books together. All right, tip number 6. I have an Instagram account, Elementary Math for Parents, where I post great ideas all the time and thinking about math. So you could go there. Just book suggestions, different tasks, fun things to do together, thinking about math. You can check that out. Then also, did I skip 7? I thought I had this all nailed down. Okay, tip number 8, come to our Zoom family math event. So at your school in April 15th and April 16th. On April 15th, we're gonna do something on math strategies for pre-K to 1st grade. It's on Zoom, just easy. Put your kids to bed, you can come attend. And then on April 16th, we're going to do core math strategies for 2nd to 5th grade. And come to both if you feel like it, or just come to one. If you totally miss it, I have online courses for parents also on my website, so you can get it that way if you're unable to attend. All right, questions. We got 5 minutes for questions. Please.
Maybe a traditional question.
Yes.
What's the goal as when you think about their readiness for middle school math?
Right.
What's the goal as far as their readiness that you want to see?
Well, if we come back, like we hope kids are going to be well versed in all the math practices, right? But we also hope they're going to meet those skill standards. One thing that's really nice about the Bridges program is there are a lot of assessments included. So the teachers have a really great understanding of where kids are and what they're going to do during those differentiation times, like workplaces, to help kids get where they're supposed to be. I can't tell you exactly one goal. I mean, we want them to be on grade level. We want them to be well versed in the math practices. Does that help? Okay, all right. Other questions?
Are those assessments that you talk about visual and
Yes,
written?
Yes. Yeah, there's a lot of visual pictures in there to help students, or the teachers sometimes allow them to use manipulatives with them. Yeah, it depends on the assessment. Go ahead.
I have 2 questions.
Please.
Does Bridges have any levels, or do you even recommend them, and what is your stand on that? And then I'll have another one.
So they have the grade levels, right? But within each lesson, there's usually a challenge piece. There's also information for the teachers. If a child is struggling, here's what you can do. So it has all that information in there. But the workplaces, which you watched this morning, are really a time. You know, some kids will say, I don't want to use 2 dice. I want to use 4. Go ahead. What would you need to do? You know, I don't want to just add up to 10. I want to add up to 40. Go ahead. What would that look like? So there's a lot of room in there for kids to come up with different ways to play the game to meet their particular needs, all the while still doing good math, you know? Yeah. Yes, please. Sorry, go ahead.
Does Bridges feed into any middle school program?
So Bridges doesn't have any one particular program, but your school's using CPM, which works really nicely with Bridges. There's a couple other programs that also work nicely with Bridges, but your school's already using one of them. So it works really well.
The other ones as well, please?
Illustrative mathematics works really well with Bridges. And then I have heard iReady, but I haven't actually looked at it myself, but I have heard that that one works too. Yeah. Any other questions? This side, you guys haven't asked a question yet? Please, go ahead.
Traditional,
Yeah.
how does it compare to traditional learning math
Yes.
in terms of levels for children? And then second question would be when they go into like middle
Yeah.
school or high school math where standard algorithms are required to, work to do their work, I guess.
Yeah.
How does this feed into that skill?
Great question. So there is this conception that because we're focusing on the visual models that we don't teach standard algorithm, but we absolutely do. So 4th grade standards are for students to know standard algorithm for addition and subtraction. That's in the standards and the kids will learn that. However, they've been working on addition and subtraction since kindergarten. So by the time they get there, they've traveled a journey of concrete understanding to abstract, and so it makes sense when they get there. I think the problem when I was in school was we went straight to standard algorithm and I didn't really understand it. Do you remember division? Is it the sister or the brother, and do I bring it down, and when do I subtract, right? I mean, this brings fear to people's faces. But if you have done enough work with the abstract, it makes sense, and you understand, and you won't have to wonder if you have 3 cookies and you divide them into 4, how many kids get it. You'll totally understand because you've done the conceptual piece. It will all make sense to you. So it flows easily because you do know that, and you're a much more flexible thinker because you know all these other things. So in terms of levels, so I have another slide that I didn't bring today, but it's a slide of a ladder because I think we tend to think of math as being like moving up the rungs of a ladder to get to the highest level. And then the next slide is a slide of the beach and the depths of the ocean, because I actually think what we're doing is so much stronger. We're going really wide like a beach, and we're going really deep like the ocean. So students become so much more flexible. Did you ever have a test when you were younger and you went to do the test and you could do the first 5 problems because they were exactly the way you did it on the homework, and then you got to problem 6 and it was different, and you were like, I don't know what to do now because this doesn't look like what I practiced? Does anybody have that experience? I'm getting a couple nods. That doesn't happen with Bridges, because we're building such flexible thinkers and seeing things in so many different ways. The manual actually says things like, write the problems horizontally and then write the problems vertically tomorrow. We really want to build those flexible thinkers so kids can think outside the box, but also be able to think themselves through a situation. They're not like locked into, what do I do with problem 6? Because it's the tiniest bit different, right? So I actually think that kids come stronger into middle school because they have that flexible thinking. Yeah. There was another question in the back. Go for it.
I was wondering, is there a guideline to the pace of introducing more further math concepts? Like if it is done addition, then we want to go on to the next level, multiplication. How do I know when to introduce?
So you can look at the standards. That gives us some idea. But you can also read those monthly newsletters coming from the teachers, and that'll give you a really good idea of where you are and where you're going next. And then also these workplace games that we played this morning, they're all available virtually also. So if you ask the teacher, they can send you the links so you can play the games virtually at home. And that is a great thing to do at home, is to continue to play the games. And like I said, you can build off of it. What if we spun the spinner 4 times? What if we each got to go twice, or whatever? There are many ways to make the games more complex and more challenging just by kind of coming up with some. The kids come up with the ideas all the time. They come, Ms. Mazzola, can I do this? Can I do this? Yes. Go for it. As long as the math holds true, You know, if they're like, can I color bunnies all over this? Well, not so much. Let's do our math, you know. But whatever they want to do in the realm of math, mostly I just say yes.
So should I just stay where the class is doing this increase the complexity of what you can do, or could I introduce concepts into the class at the level of what they're learning in the class is not?
So the thing is, we really want to build those deep thinkers. Think about our ocean. We want to go really deep. If we move ahead too quickly, the kids don't have that depth of understanding. So there's a lot of research now showing us that we want to just go deep, deep, deep. And then also go wide with an idea, like build it with these manipulatives, build it with those manipulatives, consider it in this situation, think about how it would apply over here, rather than just boom, 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 my 7-year-old's ready for calculus, right? Because their depth of understanding, if they're ready for calculus at 7, minus the exceptional very few children, they're not going to have such a depth of understanding. And they're going to break down at some point. The other thing the research is showing that I think is super interesting is that kids who have been moved too far ahead too quickly, and I'm not saying this is necessarily what you're doing, but just a little note, kids who have been moved ahead too far too quickly lose enthusiasm for math. They can do it, but they don't like it. And so they stop continuing with it because they just come to a point where they just really hate doing it because they've done so much of it. And so we're seeing that a lot with high school students, college students. So I think our number one job, K-5, keep it fun. I mean, do some really great math, yeah. But we want to keep it fun so that they keep going and they keep enjoying it. My son's actually studying electrical engineering right now, and oh my gosh, I can't understand anything he's doing. It's so complicated and symbols and diagrams and stuff like this. But I asked him, he's 21, I asked him, what has enabled you to stick with these classes? Because they're so hard. He just told me this weekend he slept 9 hours in 3 days. Who wants to do that? Nobody wants to do that. But he's studying, studying, studying. And he said, Mom, it's still fun. So he's willing to give up all his sleep, apparently, to keep doing that. So keep it fun. You know, follow your kids, see where they are and what they want to do. Yeah, yeah. All right, thank you, everyone. I so appreciate you spending part of your morning.